We are ready for our next talk. It is Back to Basics, Using Descriptive Statistics to Study the Shape of the Internet. Please welcome Emily Austin from Census.
All right. Hey, everyone. Thank you all so much for coming here to check out my talk this afternoon. I really appreciate it. I know you had lots of options for things to do, but you chose to be here, and I appreciate that. Also, shout out to the IT and coordination folks for getting me hooked up with a plugin in record speed. That was the fastest IT assistance I think I've ever had. So thank you very much. But with that said, I'm going to go ahead and get started. A lot to cover. Hopefully we'll get through it all in time for the meetup. So yeah, we're going to be talking about using descriptive statistics to study the shape of the internet today. So I'm Emily. I am currently a research scientist at Census, and I study all kinds of things on the internet. I'm particularly interested in things that have to do with security or security adjacent, but the internet at large is kind of within the scope of things that we look at. Prior to coming to Census, I was a security engineer and a researcher for about 6 years and was really focused on kind of the blue team side of things, so detection, response, lots of incident response, really focused on those types of things. And then I got my start in tech actually as an analyst on a data science team, where I worked really closely with folks in marketing and product and UX to better understand how folks were using our product at my company. And this also included people who were doing unusual things with our product, which is really anomaly detection when you get right down to it. So I was doing it even then and didn't realize it. Here's a little bit of an outline of what we'll be talking about today. So I'm going to start by talking a little bit about census data. No good analysis can begin without understanding your data. And so we'll talk a little bit about that, and then we'll talk a little bit about some descriptive statistical methods that will be useful in your exploratory data analysis adventures. Then we'll move into talking about the internet as a whole. So this talk is actually secretly really the story of my getting acquainted with census data when I first joined Census as a scientist. And so I started really broadly looking at the internet as a whole. And then we'll get into looking at census-visible risks and vulnerabilities on the internet. You can't come to BSides and not talk about some really cool risks and vulnerabilities, so we'll be doing that. And then what is probably my favorite section is looking at the internet's response to major vulnerabilities. So we'll look at 3 high-profile vulnerabilities that came out over the last year and a half, and we'll look at how the internet responded to each of them. And they're actually quite different, and I think it's very interesting and raises some interesting questions about how we as a security community can get better about patching and upgrading and fixing these things when they happen. And then we'll get into what I'm going to call the long tail. So the long tail of any distribution often has very interesting things in it. You can find anomalous things, weird, interesting things. So we'll talk about a few things there. So let's start, as I said, by talking about our data. So Census, for those of you who aren't familiar, we actually have 2 products. One is our data product, which I'll be talking about primarily today. But we also have an attack surface management platform. So this platform, if you give us a range of IP addresses or a domain, we can take that and use our attribution algorithm and look at all of this internet-wide scan data that we have and identify things that we think you own on the internet. And what we'll do with that, in addition to reporting that to you, we'll also identify any risks that we're able to see on those assets that we think you own. And that'll come into play a little bit later. But for now, let's just focus on the scan data itself. So Census scans the entire IPv4 space, and you can see kind of the breakdown of how we do that and how we prioritize different ports here. And this data is available at search.census.io, if you go there in your browser. And this is also in a BigQuery data set. So that's primarily what I'll be talking about and what I'll be using today for analysis purposes. So this is a very truncated example of the BigQuery schema for our internet-wide data set. So you can see host identifier and services. They're two of the top level fields in our data here. We have 11 of those, and those actually expand into over 1,100 fields in our data. So as you can imagine, lots and lots of interesting things to look at. Lots of sparsity in there as well because we collect different metadata about different services. So poses some interesting questions when trying to efficiently query that data. This is just a sample of what that data looks like. So this sample actually isn't particularly interesting in and of itself, but you can see you can query the data and get these types of things back. So we talked a little bit about the data. Let's talk about methods for a moment. So I am going to stand on a soapbox for a moment, if you'll allow me. So over the last few years, there's been a huge embrace in the security community of data science and machine learning and AI. And it's amazing. Quite frankly, it's actually one of the things that got me into security, the fact that these types of methods lend themselves really well to security types of problems. So malware classification, bot detection. These problems are all, there's so many interesting ways to apply data science, machine learning to security problems. But a fundamental building block that I don't think we talk about enough, quite frankly, is the underlying exploratory data analysis and kind of all of the work that prep that has to go into building some of these amazing models and getting them deployed. And not to take away from any of that. All of that is really, really incredible. But much in the same way that we think about, you've probably heard people say, well, social media is like seeing everyone else's highlight reel, but you have your highlights and your behind the scenes. I feel like we need to talk more about the behind the scenes of machine learning and AI a little bit. And so that's what I'll be talking about today. I'm going to get off my soapbox, but I think it's equally important. And quite frankly, I think it's cool as well. So we'll start here, very simply. For those of you familiar with Python pandas, you will recognize this, but in this case, df is my data frame or data set, and these are some operators that I can call on my data frame to get sets of descriptive statistics about my data. Describe will give me things like min, max, standard deviation, mean, and then mode and median as well. So pretty simple. These types of things, these values, allow us to understand the shape of our data, much in the way that you can see here. So we can understand if our data is skewed a bit, if we have right or left, et cetera. So if we know these things, if we have these measures of central tendency, we should be good, right? Like we've described our data set, and we're good to go on, right? So let's do a little thought experiment. So imagine I give you 4 data sets, and they all have the same summary statistics. Each of the data sets has an X and a Y column, and there are 11 observations or rows in each of these data sets. And column X of each of these have the same mean. Column Y also have the same mean. And if you were to fit a linear regression to these, they would also have the same regression line. So they're functionally the same, right? Like I could probably treat these data sets as equivalent. Well, here are the data sets. And so, I don't know, if you're like me, this is a little bit hard to chew through. The one thing that I guess stands out to me about this is the column X in the data set 4. It's all 8s primarily. But otherwise, it's really hard to tease apart what's going on in each of these data sets, or at least it is for me. If it's not for you, I salute you, and I would love to know your tricks and secrets. But for me, it's a little bit hard to parse this. So what we should do is, why don't we plot them and see what happens? So this is what happens. You can see in the left 2 charts, these both seem to be linear models. The one on the bottom left probably could be fit a little bit better. But then the 2 charts on the right are arguably not linear at all, and they're very, very different from one another and from the other 2. And so this is a famous data set known as Anscombe's quartet. It was created in the 70s by a statistician who wanted to really emphasize the importance of not only describing your data through summary statistics, but also through visualizing it as well. And so I mention this because most of what I'll show you in this presentation will be things like bar graphs, area charts, there'll be some packed bubble plots as well. And these are all things that have helped me understand this data a little bit better. And so I share this with you to say that it's really important to visualize your data. It doesn't have to be beautiful, it doesn't have to be fancy, but it can be very functional and also very helpful. So before we move on to actually talking about the data, I want to leave you with this quote from John Tukey, who's a famous statistician from the early part of the 20th century. And he says, exploratory data analysis is an attitude. It's a state of flexibility. And I love this quote because it just kind of screams like, just go with the flow. Like, follow the rabbit holes, look at the interesting threads in data, and just follow them. And I think it's no coincidence that many of the best analysts and researchers I've known are actually quite creative. And so I would say keep this in mind. Exploratory data analysis can often be very creative and very fun if you're willing to kind of dig a little bit and follow those threads. So now let's talk about the internet as a whole. Hop in your time machine for a moment and come back with me to 1969, when the precursor to our modern internet was the new hot thing, the ARPANET, with its 4 nodes connecting several research institutions. So it's just kind of nice to remember these sort of humble beginnings, I think. And then fast forward 30 years to 1999, and this is from the Internet Mapping Project, and it's showing relationships between some of the major ISPs. And you can see that even within 30 years, there's been, like, from 1969 to 99, there's a tremendous amount of growth and change on the internet. There's actually a paper I found from the late 2000s that suggests that the internet's growth actually follows Moore's law and will double in size every approximately like 5 years or so. And this is in relation to like autonomous system connections. So kind of mind-boggling if you think about that. So we can look at the internet now. This is a look at different hosts, or essentially IP addresses by city in the US. And the hotter regions here represent like hundreds of IP addresses. So we've come a long way from those 4 nodes on the West Coast. I guess we're technically in the West right now, but we've come a long way from those 4 nodes. And I think that's pretty cool. Like, that's really interesting. And so now I think it makes a lot of sense to look at, well, what's on the internet, right? So I won't show code for every one of these examples, but I do want to orient you just a bit to what I'm looking at and what I started looking at. Again, this is Python pandas in a Jupyter notebook, just reading in a CSV. And you can see here on the bottom, like, the different fields that I'm looking at. So this is a data set of service name, port, and service count over a series of dates from June of 2021 through May of 2022, with several different snapshot dates in there. So if we look at the number of services that we actually have in this data, it's quite a lot. I mean, well, a lot is relative, I suppose, when you're talking about the internet. This is really not a lot in terms of the internet, but 106 is a lot to start with. So I wanted to just kind of look at maybe the top 20 and start there. Because again, I'm new to internet measurement research as of this year. And so I really had no idea what to expect. So I was like, I'm going to bite off just a little bit of this and get started. So here, we can put this data into a crosstab and essentially compute percentages for each of these dates that are columns. We can compute what percentage each service represents for each of these dates. And then we can plot it, because quite frankly, this is a little hard to make sense of. So here's what we get. And I'd like to direct your attention to the fact that this is not actually a bar chart. This is a time series heat map. So as you can see, HTTP is really, really dominant. In fact, it's 81% of the services that we see on the internet, or did during this time period. So it's a lot. But the thing with this, so this is like this HTTP is a whole order of magnitude larger than anything else that we're seeing. So I want to kind of dig a little bit deeper because I can kind of make out some different variations of color here, but it's really hard to pick apart. So if I take out HTTP, here's what I get. So now we're kind of dealing with things that are a little bit more on the same order of magnitude. And this is from snapshots of about 220 million services or 220 million hosts, excuse me, for each of these dates. So you can start to see SSH, SMTP, FTP. These are pretty popular services that we see a lot of on the internet. But just for relative comparison's sake, HTTP, I mentioned, is about 81% of the services on the internet. SSH is 3%, at least in this data that we saw. So to give you an idea of kind of scale and proportion. But let's go back to HTTP for just a moment. Because anytime you're dealing with a data set that is so, has such a tremendous, chunk of things that are all one flavor, it's probably a good idea to parse them apart into finer details, right? And so this is just a dashboard that I put together when I was exploring this data to better understand HTTP kind of on the internet. So this map here in the top left represents where HTTP services run just by counts. You can see that the US, obviously we have a ton. China and Germany, actually, it's a little hard to make out with the magnitude of the US, but also quite popular there. In the top right is just distribution of ports where we see HTTP run. And then on this bottom row, in the far left corner, we actually joined up our internet-wide scan data with a data set called ASDB. It's a project out of Stanford University, and it categorizes autonomous systems into different industry buckets, which makes it a little easier to kind of compare things over time and also to each other. And then in the middle and bottom right of these corners, of this row, you can see some of the different vendors and products that we see. So yes, HTTP is web servers, websites, but there's also things like proxies and caches, load balancers, APIs. So HTTP, lots and lots of different things run on HTTP. I hesitated with whether to share this set of graphs, but because it doesn't actually show anything quantitatively. It doesn't tell you anything quantitatively about these different services. So just to orient you here, so for each of these, for instance, we'll look at SSH. This large bubble represents the proportion of SSH services that we see on port 22. You can see 2222, much smaller, but still larger in size than a lot of these others. So it's the proportion of services running on a given port. And I say I hesitated to show this, but I realized when I was going through and kind of doing this first pass analysis, this visual actually really helped me initially to understand kind of the way some of these top services are distributed on the internet. So HTTP kind of runs everywhere. In fact, of the 65,535 ports we see in this particular snapshot of data, from March 15th, we saw it on 65,532, I think. So it's quite literally everywhere. And I'm sure had I picked a different day, those other two ports would have also been represented. But you contrast that with SSH and FTP, and you can see that they are much more commonly run on their IANA assigned or assigned port. And then SMTP is kind of a whole other thing too because of secure SMTP, deprecation of ports and that kind of thing. But either way, I think, again, this kind of speaks to the power of visuals, I think. So 27 million SSH instances, 75% of them run on their assigned port. And this is just from one snapshot date, by the way. So this is one date that we see this many SSH services. So kind of digging into this, I was like, well, maybe it makes sense to look at SSH versions because that seems like an interesting thing to look at. And you can see OpenSSH, obviously really popular. But if you'll notice down here, so this data is at the software level. So each row represents a different software version. With the total number of observations of it that we see in the right column. And if you see at the bottom of the slide, we apparently see 179,000 different flavors of SSH, which, again, I'm not an internet measurement expert and certainly was not at the time, but that seems a little weird to me. So remember that. We'll look at that a little later. But for now, we'll look at the most common SSH versions. Again, trusty bar plot, like who doesn't love them? So I'll point out that this graph is also log scaled. But you can see, like, OpenSSH is really popular. This is probably not surprising to most folks in the room. And I think kind of the good news is, like, these are mostly newer versions, right? It's not until you get to, like, down here where you see OpenSSH, like 6 something. I think those were released in 2014, which maybe a little older, but, you know, not too bad overall. So let's look at SSH ciphers next. And this, to orient you, this is actually out of percentage of total instances. So most of these, 75% of these actually, are either an AES algorithm or Poly 1305. However, as of March 15th, when this particular data was collected, we see a whole lot of triple des still out there, which is a little bit interesting because that was deprecated, I think, or suggested to be deprecated in 2017, I think. And that's like 10 million services that are still running that. And you can also see some blowfish over here, which, again, has been deprecated in favor of twofish, I think. So overall, like 75% of these are pretty good, but like we could be doing better with these millions of services. So let's shift a bit to looking at FTP. Talked about SSH. We kind of grazed the surface, but that's okay. This is exploration. 91% of FTP that we see is on port 21. However, when I was looking at this for the first time, I realized that about 3%, so the next most common port that we see FTP running on, is 40,029. And I thought, well, being, again, new to internet measurement, maybe this is just some obscure service that I don't know about. Like, this is probably just a thing, right? So I went to census search, and I do this a lot, where like I'll be querying data in a SQL database, and then I'll kind of pop over here to just sort of dig and poke at things via a UI. And I looked for FTP services running on port 40,029. The thing that immediately stood out to me is that almost all of these are on an Alibaba Cloud autonomous system, which I'm not really entirely sure what's going on there. In fact, if anyone here knows or has some theory on what that might be, I would love to talk to you afterwards, because this has puzzled me for a while. And I kept digging. And so like port ranges used by Microsoft, I did notice that anecdotally a number of those FTP services did seem to be, I think, a Microsoft flavor of FTP, if I remember correctly. But still, really odd, and I'm just really curious. If anyone has any thoughts about that, I would love to talk to you afterwards, because that's kind of strange. Okay, so we've talked about services on the internet. Let's talk a little bit about where they run. This tweet lives rent-free in my head. I think about it a lot, and I find it really funny. Because there's a lot of truth to it, but also there's a lot of nuance that makes it not so true. So let's look at that. So this is a graph of hosts and services by autonomous system. I think this is top 20 or 25. And it's sorted by hosts, and you can see, Amazon is at the top. And I'll point out, this is just one of Amazon's autonomous systems. There's another one somewhere down here. And there are others as well. These are not all of Amazon's autonomous systems. There's lots of them. But then we can also look at this sorted by services. So instead of just looking at, in this case, host being like an IP address, we can look at services. So services would be like SSH, FTP, etc. Amazon is still at the top, this particular AS, but you do see a little bit of shuffling, right? So like OVH, and you see some other cloud providers, like I think DigitalOcean appears down here. You can kind of start to see that and how some of these cloud providers do tend to run lots of services on the internet. But one thing I'll point out is in looking at Amazon, Google, Microsoft Cloud, and I think I believe Oracle as well, only about 9% of things on the internet, 9, not 90, 9, run in one of those clouds. And so there's this idea, going back to the whole thought of like the internet is the web's decentralized, and then US East 1 goes down and everyone's losing their minds and it's trending on Twitter and oh my God, the world is ending. But I think it has a lot to do with the fact that it's popular things. It's things that are integral to our everyday lives that are actually in these clouds, and increasingly so, that makes it feel so impactful when some of these go down. So I would argue that the internet itself is not quite as centralized as some people are kind of maybe making it out to be, but rather that it's about the content of what we have in those clouds rather than the spread of actual services. So now let's talk a little bit about risks and vulnerabilities on the internet. So we chose a couple of dates, about 6 months apart, and sampled 2 million hosts from each of these dates from our universal internet data set. So it's a total of about 4 million hosts. And then we ran each of these hosts through this risks engine that powers our attack surface management platform. So remember I mentioned earlier how we'll find your assets, but we'll also find risks on your assets. So this is that same technology, but we just used it for a slightly different purpose. Before moving on, I do want to throw out 2 caveats about the data I'm about to show you. So I very carefully said, well, not on this slide, but I very carefully said at the beginning that this would be census visible risks and vulnerabilities. And I want to put that caveat on here because for us to see a risk or a vulnerability in the way that I'm about to show you, there are 2 things that have to be true. The first of which is that there must be some public internet-facing artifact that we're able to see from passively scanning the internet to be able to detect something. So for instance, maybe it's a banner that says hacked, or maybe it's a software version we're able to discern from passive scanning that will show us, that we know is a vulnerable software version. So it has to be something that's public internet facing. And then the second thing that has to be true is much in the same way that an IDS or an IPS can't fire without signatures, we have to have a fingerprint written for a particular risk or vulnerability to have it included in this data I'm about to show you. And so as of now, I think we're around 250 or 300 different risk fingerprints. I think it's closer to 300. But I would keep that in mind, and I will say, so there is definitely some bias to this data, which I think is really important to acknowledge, that this is in no way everything on the internet. It's what we're able to see and what we're able to capture. So we group our risks and vulnerabilities into kind of 3 categories. You can see them here. I won't read these definitions to you. But I'm curious, by show of hands, how many people think misconfiguration is the top risk on the internet? I'm going to ask about all of them, so. Okay. How many of you think that exposures are the most, like the top thing we see on the internet? Okay. How about vulnerabilities? How many of you think vulnerabilities are the things that we see most of? Okay. All right. I'm gonna give you a cliffhanger here for a moment and just talk about the risks themselves. So you'll notice, yes, there are lots of exposures here. There are lots of EOL or end-of-life software on this list. And again, this is a function largely of what our data is good at seeing, because we're not a vulnerability scanner. We don't attempt any kind of intrusion, or we don't attempt to access anything. This is all passively scanning what's out on the internet. And so I want to talk through these top 3, because I think they're kind of interesting. So the first 2 actually, the first 2 being missing common security headers, so missing content security policy, and then self-signed certificates, just self-explanatory. I don't think they're hugely concerning in and of themselves, right? We actually assign them a risk severity of low, I believe. And it's not that they're not problematic. It's just that on their own, they are probably not going to be the thing on their own, not chained with anything else, that are going to get your crown jewels taken from you, right? They'll probably be chained with several other things to make that happen. I will say that if I were an early security hire at an organization and I saw lots of flags for this kind of thing, like no security headers, lots of self-signed certificates, that would be a sign to me that perhaps other security concerns might be sort of flying under the radar. And so while I wouldn't necessarily think that those were the alarms, they would be little small red flags, maybe pink flags, if you will, that would make me think, maybe I should go talk to the dev teams and kind of see what's going on. However, unencrypted weak authentication page is a risk I want to talk about. So this specifically refers to authentication or login pages that do not use TLS, so everything's transmitted over HTTP, and they use either basic or digest auth. So they're sending credentials over the wire, either plain text or MD5 hashed, which is, no one should use that for security purposes ever. It's like base 64 encoding. So really insecure ways to transmit credentials. This is actually a really huge problem in my opinion. So credential theft is not going away. It's a very old tactic, but it's not going away. All of the data breaches, all of the things for sale on the dark web or on these forums, they're credentials. They're stolen credentials. And in fact, the 2022 Verizon Data Breach Investigations Report actually names, I believe it's stolen credentials, as one of the top threat actions, or action varieties rather, that they see in breaches and incidents. And so I want to point out, this is still a really common problem, and it has not gone away. And so this is something I would want to fix. That's something that I would be digging into very quickly. Okay, so here are the numbers. I gave a little suspense there, hopefully. Here are the numbers for the different categories of risk that we see and the relative percentages they make. So for those of you who said misconfigurations were the top thing on the internet, congratulations, you are correct. They represent about 60%, they represent 60% of the risks that we see on the internet. Exposures are 28% and vulnerabilities are 12%. Again, I will say there is certainly some inherent bias in this data because of what we're good at seeing and detecting. But I also think that this is a really interesting perspective because we make there's a lot of noise. Words are hard. There's a lot of noise around 0 days, really hot vulnerabilities, really cool technical exploits. And I mean, they are cool. I mean, I love reading about them too. But the reality of what is actually going to get a company breached is probably very different, and particularly if you look at this data as evidence of where the problems are, right? So while the vulnerabilities are really exciting to talk about, I think it's probably more likely that security hygiene is the thing that's worth investing in long-term overall. So now let's talk about the internet's response to some major vulnerabilities. So this is an area chart that shows the internet's response to the Log4j vulnerability. This line represents when the disclosure happened, and you can see almost immediately, so these snapshots the axis shows bi-monthly, but they are monthly. And you can see almost an immediate, sharp trend upward in terms of not vulnerable versions, this darker purple. And you can also see a sharp decline in vulnerable versions. So people really jumped on this. I mean, it was everywhere. It was a terrible time to be in security operations or in security or in IT, or quite frankly, if you're in software engineering in a small company. It was just a really bad, really stressful time right around the holidays. And so people responded to this really quickly. And again, it was very severe, so it made sense that people would take it very seriously. And it was also everywhere. God, I think we're still finding places where it exists. So let's contrast that with the internet's response to this GitLab vulnerability. It was a remote code execution vulnerability. And the actual disclosure happened a month before the data on this chart begins. But what I'll say is you can start to see this dark purple that's not vulnerable. You can see there's a steady trend upward. We're good, we're good, we're good. We're patching, things are happening. And then we get here. This is November 3rd when there's a tweet that goes out a tweet that goes out that's saying that, hey, this GitLab vulnerability is being exploited and used in a botnet that's DDoSing people. And then people started paying attention. People were like, oh, we got to fix this. And so you start to see this curve trend a little bit more sharply upward because people were like, oh, this seems like a big deal. It caught on. It got popular, which is something we'll talk about in a moment. And then finally, for this section, I want to talk about the Confluence vulnerability. So this was an OGNL injection vulnerability. And it was disclosed here. I believe this was in May. I'm totally misremembering. In August, I'm sorry. This was in August. And so, again, you see very quickly things start getting patched. But what's really interesting to me about looking at this data for Confluence, which might not have been as immediately obvious if I had not graphed this, is there's a whole lot of empty space up here. Because people took Confluence servers offline as a response to this disclosure. Which makes me wonder, who is out there running Confluence just as a hobby? Are they just, do they just have them floating out there and they're like, oh, well, now it's vulnerable, I guess I'll turn it off, I don't really need it anyway? What's going on there? I think this is a really interesting phenomenon. I'm still not quite sure that I've wrapped my head around the reasoning why. But there are a lot of differences in the way these responses happened, right? We looked at the curves. We kind of talked about time to patch after the disclosure. Log4j was immediate. GitLab took a botnet to get really, really popular. And Confluence just people started taking things offline. Things just went away because no one wanted their Confluence servers anymore, I guess. So for whatever reason, when I think about these things, I always think about untangling lots of tiny necklaces that are tangled together. Because I think there are a lot of elements to pull apart with what's going on here and what caused these responses to be so different. So this is a screenshot from Google Trends for Log4j. And you can see that it hits its peak right there around, this is in December, in December. It got really popular. It hit peak popularity per Google Trends, which I'm not saying this is a super scientific way to look at things, but I do think for kind of measuring general societal awareness or curiosity about things, it can be useful. And then compare that with kind of a similar thing for the GitLab vulnerability. And you do see a little bit of a jump here when it was released in May. But it doesn't actually start to get traction. It doesn't hit peak until much later that year. This is actually in December, which is a month after that tweet went out talking about, hey, this is being used in a botnet. So I think there are a lot of different elements that go into this. I'm particularly interested in looking further into things on Twitter as far as how those relate to how popular a vulnerability gets, to how much awareness gets brought to it. Because I think there's something we can do better as a security community there. I don't know exactly what it is, but the variety of responses in all of these, they were all pretty severe. Log4j, yes, arguably probably the worst. But it's interesting to see how people respond to these things differently in aggregate. So now I'll get to the long tail. I had to cut this to just one example because I wanted to make sure there was a little time afterwards. But I mentioned, before, I think I talked about 179,000 versions of SSH software. Seems real weird to me. So I started looking at the tail, and you can see none of these are not real. This is not real. I actually don't know entirely what this is. This could be a script gone awry. This could be something broken. These could be hacked instances of things. Possibilities abound. But there are several thousand of them in this data set. So there's that. And I was like, okay, well, let's look maybe at just OpenSSH versions, of which there are also a lot in this data set. But you can see that there's also some weirdness here. OpenSSH hidden, OpenSSH mock, welcome. Lots of really unusual, too many spaces, just lots of weird things going on here. And so I was looking at this. I was actually just looking at this manually, kind of scrolling through and seeing what was out there. And I found this. So I found this in March of this year. The current version of OpenSSH in March of this year, I believe, was 8.9. OpenSSH 9 got released in April. So this doesn't exist. So what is this? So a colleague and I started kind of Googling around and trying to figure out, like, did we travel to the future? What is going on here? So we found this from like 5 years ago. So this has been going on for a while. Or someone reports finding something very similar. Like they've done an Nmap scan and they're finding like OpenSSH 12 and they're like, WTF, that's weird. And one of the top answer rather, is that this is deliberate. This is a thing that someone's actually broadcasting for some reason. I'm not going to speculate as to why. It seems to be associated with a particular firewall vendor who may or may not be interested in not broadcasting their SSH version to the internet, to pen testers, to whoever. I won't go into that, but there are theories on why this might be the case. But I'll point out that like things like this they abound on the internet. The internet is a huge, huge place. And this is just one tiny example of something that we were able to find just from kind of digging in and looking at kind of getting away from the bulk of services and the bulk of things and looking at things kind of the end of the tail of the distribution. Okay, so why does any of this matter? Who cares? What does it mean? So I think there's two main things that I hope you'll walk away with from this. And the first is that really good exploratory data analysis or descriptive statistical analysis is critical for asking better questions, doing better analysis, building better models. It's really important. Like you shouldn't build models on top of data that you don't understand. You absolutely can, but this is one of those, we were so consumed with whether we could, we didn't stop to think whether we should. You shouldn't. Because that exploratory data analysis gives you a sense of, what to do. Like, you're going to run into missing data. You're going to run into issues with it. And so what are you going to do? And having the context around the data set itself and kind of understanding how common these things are within your data set are really important. And then secondly, from a security practitioner perspective, one of the things that, like, putting my security engineer hat back on for a moment, using data analysis, like, you don't have to be a data scientist or an analyst to make use of things like this. And certainly, I hope folks who are not in these roles are also doing this kind of stuff. If you're a security engineer, if you are a security operations center analyst or researcher, being able to look at data like this and figure out the important pieces of it and pull out things that are really relevant to you or to your organization are really important, because we know that now more than ever there's alert fatigue. Like, alert fatigue at this point is almost kind of a joke, because it's just it exists, and I don't know that there's any solution to it that's viable at this point. And so being able to comb through data and figure out, okay, you know what? I see that we have 20 vulnerabilities that are in. We have 200 vulnerabilities. Our pen test found 200 vulnerabilities. I am one security engineer in a mid-sized organization. What do I do? Where do I focus? Well, maybe I can look at what's being exploited in the wild. Maybe I can look at the most common risks and vulnerabilities that exist on the internet and get a better sense of how to structure my approach and where I'm going to have the most impact early on. So I think it's a double-edged sword. Well, maybe that's a terrible analogy. It's not a double-edged sword. It's two swords. It's two swords, two samurai swords, because you get to know your data better. It helps you prioritize things, and it's very helpful all around. So thank you all so much for taking the time to come to this session. I really, really appreciate it. Again, you had lots of options for other talks you could go to, so thank you for coming to this one. And I would also really like to thank the Census research team. So Mark and Himija and Mark and Zakir, I really appreciate all of you. Like, research is a team sport. None of this happens solo. None of this happens in a vacuum. And, it really helps to have an amazing group of folks to, like, kick around ideas with and explore things together. So with that, I will leave you with these two QR codes, which are certainly not sketchy at all. One of which is actually this. I'm not going to spoil a surprise. You can check it out. But the one on the right, if this data was interesting to you, looking at the internet as a whole, looking at vulnerabilities on the internet, if this is interesting to you, keep an eye out for our 2022 State of the Internet report. So that's going to be coming out the first week of September. And it's going to have all of this kind of data in it. There will be some more stuff that I didn't even touch in today's presentation. But if you sign up now, like you can sign up to get on the list to be notified when it gets released. And if you do, I think you'll be entered into a chance to win 6 months of our pro data, which is essentially the data that I've used to do all of this analysis. So I think that's a cool perk. I would be super excited to have 6 months of that for free. And yeah, I really appreciate you all coming out. Thank you so much. And I won't hold you from the Security Data Science meetup. I know people are probably eager to get to that. But I think I have a few minutes for a couple questions, and then we'll let people head to that.
Hello? It's not on. Is it on?
I think it's on. I can.
So I was just looking at the index of the screenshots that you shared for the open SSH data, and I saw that basically for the open SSH, your index was in the 600s and their count was already 1. So that made me wonder if actually that means that out of the 17,000 SSH services that you observed, like almost all of them have a count of 1, and you only have a couple of hundred with a count larger than 1. Is that correct?
Yeah. Yeah. So the question was pertaining to like how many of those SSH at the end when I showed some of the tail of the SSH version distributions. So many of them were 1, like even into the hundreds, there were just 1 of them. And so the question is it possible that there's probably just maybe a few hundred real versions? I think that's probably the case. I think I would say with almost certainty that is probably true, because I do not think, maybe I'm wrong, I don't think there are that many versions of SSH software in existence. So I think you're probably right. It's very much concentrated within like maybe a few hundred, if that.
Hey, good talk. So on one of your slides, you had a dashboard that you were using for some analysis. I was just wondering what tool that was made with, and what was the data on the back end?
Sure. So the question about the dashboard. So that was Google Data Studio. Connects right into BigQuery, makes it kind of easy. Well, easy again is kind of relative, but it makes it simple to connect data to make those interactive dashboards. And then the data on the back end was a subset of our internet-wide scan data that I had filtered down to just HTTP services with some of those attributes on it. And in fact, let me see if I can go back to where that was and look at that. Oh, no, let's see. Wow. Okay, wow, sorry, that took a long time. Felt like a very long time. So on the back end, it was literally just a pared down version of that internet-wide scan data, but joined up with this industry data from ASDB, and then vendor, product, port, and geolocation, or like country level data. Those are all just things native to our data. So I pulled those out into a separate table so I wouldn't have to query the whole thing all the time, because that gets a little bit prohibitively expensive. So yeah, just an HTTP table on the back end. Yeah, absolutely. Cool. Any other questions? Does anybody know what is up with the 40,029 FTP? Anybody? Anybody have theories? Please. This is kind of like I just need to go sign up for an account and stand up some instances on Alibaba Cloud and see what happens, I think. Awesome. All right. Well, thank you all so much. And if you did not get to the QR code on the left, that's actually just some sample searches for census search and some resources for threat hunting with census. It's really not malware. So I'll leave that up. But thank you all very much. This is great.